All right. So you're out there wanting to really step up your game dev game, right?
Hmm.
Wanting to build those games with code that just sings, clean, efficient, ready to grow as your game grows.
Well, you've come to the right place.
That's what we're all about in these deep dives. And today, we're cracking open this book.
Level up your code with game programming patterns.
Ooh, yeah.
We're going to unlock those secrets.
We're going to help you write future-proof code. It's almost like getting those cheat codes, but for, writing really elegant code.
It's true. These design patterns, they're like having a master class in problem solving, but specifically for game development.
Okay.
It's like you're tapping into the knowledge of all these other developers who've been there, done that, so you don't have to reinvent the wheel every single time.
I love that. No reinventing the wheel. We're all about working smarter, not harder, right? So we've got this book. It's all about design patterns. But I can imagine someone who's just starting out, they might be thinking, why should I even care about this? I just want to make my game work.
Yeah, I get that.
Yeah.
And it's easy to get caught up in just making things work.
For sure.
But imagine this. You've poured your heart and soul into this amazing game. It's got all the features, but then as you keep adding more, it starts to feel really fragile, like one wrong move, and the whole thing could just, collapse.
Yeah, like a Jenga tower.
Exactly. Design patterns help you avoid that.
They're like the support beams.
Exactly.
Okay, so it's not just about making the code pretty. It's about making sure that it's got a really strong foundation for the future.
Exactly. And here's the thing. You might be surprised to learn that you've probably already used some design patterns without even realizing it.
Oh, really?
Yeah. Think about the game loop.
Okay, the heart of every game.
Right. It's constantly updating, checking for input, rendering graphics. That right there is a pattern in action.
Mm-hmm.
Even using prefabs in Unity, that's a version of the prototype pattern, which we'll be diving into later. So you're already using these concepts. We're just going to bring them into sharp focus.
I love that. We're going to put on our design pattern goggles. I never even thought of it like that. Now, the book kicks off by talking about these solid principles. And that sounds a little bit intimidating, to be honest, like we're laying down the law. What's the deal with solid?
Think of SOLID as the building code for robust, maintainable code.
Yep.
It's an acronym for 5 key principles, and they all work together to kind of help you avoid some of those common pitfalls that we run into. It might seem a bit theoretical at first, but trust me, understanding these principles can completely change the way you approach coding, especially as your projects become more and more complex.
Right.
You really start to appreciate it.
All right. I'm convinced. Solid foundations it is. We're laying down the law.
Okay.
So let's break it down. What's the first rule in this code of conduct?
First up, we have the single responsibility principle.
Okay.
And you know how in a game, you don't want one character that's trying to be the hero, the healer, and the quest giver all at once.
Too many ats. They'd just be like totally ineffective.
Yeah. Exactly. It's the same with your code. Each class should have one specific job.
Yeah.
If you have a class that handles player movement, it shouldn't also be responsible for playing sound effects or managing your inventory.
Okay.
That's just asking for trouble.
Yeah. So it's all about keeping things organized, like having that perfectly organized toolbox where every tool has its place.
Yes, exactly.
Love it.
And that actually brings us very neatly to the next principle, which is open-closed.
Okay.
So imagine you want to add a new enemy type to your game. You wouldn't want to go back and rewrite all your existing code just to accommodate this new enemy.
Right. Oh, that just sounds like a recipe for disaster.
Yeah.
Especially when you're on a tight deadline.
Exactly.
Yeah.
The open-close principle says that your code should be open for extension, meaning you can easily add new features, like our new enemy type, but close for modification, meaning you shouldn't have to mess with the existing working code.
Right. And that's exactly what this principle helps us achieve and, kind of ties into the next principle we'll talk about. So imagine you're building like a racing game, right? And you might have like a base class for vehicle.
Okay.
And then you have like subclasses like car and motorcycle, right? And this is like a common concept called inheritance, where you're basically, taking properties and methods from this base class.
Yeah.
But what happens if your motorcycle code suddenly prevents your vehicle from refueling? Because motorcycles don't have car doors, right?
That's where the Liskov substitution principle comes in. It basically says that any code using that base vehicle class should work perfectly fine with any subclass like car or motorcycle without breaking down each subclass. Needs to really fulfill the promises of its parent class.
Oh, so it's about making sure that your subclasses are true to their heritage. No weird quirks that break the game's logic.
Exactly. Now let's talk about keeping things tidy. You wouldn't want one giant interface controlling everything in your game, right?
Oh, gosh, no.
That'd be like having one remote control for your TV, the sound system, the lights, the thermostat. It'd be overwhelming,
I can barely handle a single remote.
right? That's where interface segregation steps in. So instead of one massive interface, you break it down into smaller, more focused ones. Think of it like this in your game. You might have characters with different abilities. Some can jump, some can shoot, some can cast spells. Instead of having one massive iCharacter interface with everything, you create smaller interfaces like iMovable, iShootable, iMagical, and so on.
Okay.
This way, each character class only implements the interfaces that are relevant to its abilities,
Got it.
making your code much more organized and less prone to those like fix one thing, break everything situations.
It's like giving each character their own specialized tool belt instead of one giant clunky one they can barely carry.
Exactly. And finally, we have the dependency inversion principle.
Okay.
Remember that house analogy?
I do.
You wouldn't want your electrical system directly wired into your plumbing.
Oh no, sparks leaks, game over.
Yeah, you want to avoid that.
Yeah.
So in code-tight coupling basically means that if you change one class, it can break other classes that depend on it.
Okay.
The solution.
Yeah.
Abstractions. So instead of classes being directly dependent on each other, they depend on interfaces or abstract classes. This creates this flexible system where you can swap out different parts without bringing the whole house down.
So it's less like a house of cards and more like a well-designed machine where each part can be replaced or upgraded without throwing everything out of whack.
Exactly. And these solid principles really set the stage for us to understand and apply design patterns. Effectively, they're the guiding principles that lead to cleaner, more maintainable, and scalable code. So once you internalize these, you'll be able to write code that can stand the test of time, even as your game grows in complexity.
Awesome. All right, solid foundations check. I'm feeling very grounded and ready to tackle some actual design patterns. So where do we go from here?
Well, the book jumps right into some practical examples, and they focus on patterns that are super relevant for game development, especially in Unity, and they even provide some C# code snippets
Ooh.
to illustrate how it all comes together.
Nice. Nothing like seeing it in action. So which pattern are we tackling first?
The factory pattern, and trust me, this one is a game changer, especially if you find yourself spawning lots of objects in your game.
Okay, spawning objects. I feel like that's pretty much every game ever, so tell me more.
Okay, so imagine you're making like an RPG, and you've got all these different enemy types. You got goblins, trolls, dragons, the whole shebang. Instead of writing separate code to instantiate each one.
Which would get messy fast.
Yeah. Exactly. The factory pattern lets you create this central factory object that handles the creation of all these different enemy types.
Okay.
Imagine it like an assembly line in a factory. But instead of cars, it's churning out goblins and trolls.
Okay, it's like a magical creature assembly line churning out goblins and trolls. I like where this is going.
Right, and the beauty is you can feed your factory different instructions, and it'll spit out the right kind of enemy, all shiny and ready to fight.
This sounds amazingly efficient, and the book actually gives us an example of how to build this in Unity, right?
It does. They use a very simple example of like a level building scenario where you might be spawning things like trees and rocks and power-ups.
Right.
But the core concept is the same.
Awesome. So let's say I'm sold on this whole factory pattern. What are some key things to keep in mind when I'm actually implementing it?
Well, a big one is to make use of interfaces or abstract classes.
Okay.
This lets you define like a common blueprint for all your objects, even if they have different behaviors.
Right, because even though a goblin and a dragon are very different, they're both still enemies at their core.
Exactly. And by defining those shared characteristics in an interface or an abstract class, you make your factory much more flexible and adaptable.
Got it. Any other pro tips for aspiring factory owners out there?
One thing that the book emphasizes is the importance of keeping your factory's code really clean and focused.
Okay.
Remember the single responsibility principle from Solid,
Yes, one class, one job.
right? Your factory's job is to create objects, not to micromanage their every detail. So keep the object-specific logic within those objects themselves and let the factory handle the assembly.
Delegation. A good factory owner knows how to delegate. Okay, so we've got factories covered. What other patterns does this book delve into?
Well, remember how we were talking about performance being like a big deal in game development?
Of course, nobody likes a laggy game.
Right, and one common culprit for those performance hiccups is instantiating and destroying lots of objects during gameplay,
Yeah.
especially if those objects are very complex.
Okay, yeah, I can see how that would put a strain on things.
And that's where the object pool pattern swoops in to save the day.
Ooh, object pool. It's all about recycling, isn't it?
You got it. So imagine you're making like a bullet hell shooter
Okay.
And there are hundreds of bullets flying around on screen, instantiating and destroying each one. Every single frame would bring your game to a crawl.
That sounds computationally exhausting.
Right, so instead of constantly creating and destroying, you create a pool of bullet objects at the start.
At the start and then just reuse them.
Exactly.
So when a bullet goes off screen, instead of destroying it, you just chuck it back into the pool ready to be fired again.
Precisely. And this way you avoid all those performance-heavy instantiation and destruction calls, keeping your game running buttery smooth.
That's amazing. I can see how this would be invaluable for anything that involves a lot of similar objects being created and destroyed really rapidly, projectiles, particle effects, maybe even enemies in certain types of games.
You're getting it, and the book provides like a really neat implementation of an object pool in Unity using stacks.
Okay.
But you can customize it to use other data structures as well.
Now, I'm curious, are there situations where an object pool might not be the best approach?
Yeah, that's a good question. Like any tool, it has its trade-offs. So if you're dealing with objects that are very, very memory intensive, or if you're not actually creating and destroying that many objects in the first place, an object pool might be overkill.
Right. We don't want to over-engineer things unnecessarily. Always good to weigh the pros and cons. Okay, object pools. Check. What other secrets does this book hold?
Well, it wouldn't be a deep dive into design patterns without talking about the Singleton pattern, would it?
The Singleton. I've heard whispers of this one, both good and bad. It's like the double-edged sword of design patterns.
That's one way to put it. It's definitely a pattern that's often misunderstood and misused,
Okay.
but when used appropriately, it can be quite handy.
Okay, so enlighten us. What is the Singleton pattern, and why does it have such a controversial reputation?
At its core, the Singleton pattern ensures that you only have only one instance of a particular class in your entire game. Think of it as like, that one-of-a-kind item you find in a game, like a legendary artifact.
Okay.
There's only one, and everyone knows it when they see it.
Okay. A unique artifact. Only one of its kind. I can see how that translates to code. So how do we handle this precious artifact in our code, and why all the controversy?
Well, you access it directly from anywhere in your code.
Okay.
No need to pass it around as a reference or anything like that.
Yeah.
But here's the catch, that easy access can be tempting, too tempting.
Okay.
Developers can fall into the trap of making everything a singleton.
Oh, no.
And that's when things get messy.
So it's like having that one friend who's always the life of the party. Everyone wants them around, but too much of a good thing can be overwhelming.
Yes, exactly. Overusing singletons can lead to what we call tight coupling, where different parts of your code become so intertwined that changing one thing can break everything else.
Yeah, not ideal.
Not ideal at all.
So it sounds like the singleton pattern needs like a firm hand, some clear guidelines. When is it okay to invite this life of the party to our code?
Think of those essential one-of-a-kind elements in your game, like a game manager that keeps track of everything.
Yep.
Maybe an audio manager, a save load system. These are things that you only need one of, and they need to be accessible from everywhere.
Right.
But even then, it's important to use singletons strategically, not just as a shortcut.
Okay.
The book talks about some techniques like lazy instantiation, which basically means you only create the singleton when you absolutely need it, saving precious resources.
Smart. So it's all about finding that balance, leveraging the singleton's power without letting it kind of take over our entire code base.
Exactly.
All right, singletons check. What other gems does this book have in store?
Let's talk about giving orders. And I'm not talking about micromanaging your players or anything.
Okay, I'm intrigued. What's the command?
It's actually called the command pattern.
Okay.
So imagine this. Instead of like directly calling methods to move your character or fire a weapon, you encapsulate those actions as separate command objects.
Okay.
Think of it like a game of strategy where each move is like a calculated command.
Okay, so instead of just making things happen, we're issuing commands. What's the advantage of this more strategic approach?
Well, it brings a whole new level of flexibility and control.
Okay,
With command objects, you can store them, you can queue them up, you can even undo them. Imagine implementing like an undo redo feature in your game's level editor.
yeah.
That command pattern makes that a breeze.
That's huge undoing mistakes. A lifesaver, especially in game development where we're constantly experimenting, but doesn't creating all those command objects add like a lot of overhead to our code.
That's a valid concern. Like any design pattern, it's a trade-off.
Yeah.
So if you're building a game where actions need to be reversible, or if you need like complex sequences of actions, the command pattern is your best friend.
Okay.
If not, it might be a bit overkill.
Right. Choose your battles. No point in over-engineering things. So what about those moments where our game characters need to switch gears, like change their behavior on the fly. How do we manage that elegantly?
Ah, you're talking about the state pattern. And it's perfect for handling those kind of dynamic situations. Think about like the different states a character can be in idle walking, running, attacking. Each state has its own unique behavior.
Right, and trying to manage all those behaviors with just a bunch of if-else statements would quickly become a nightmare.
Exactly. The state pattern lets you encapsulate each state as a separate object with its own logic and transitions. It's like giving each state its own little script, so to speak.
Okay, so instead of one giant brain trying to handle everything we delegate, each state knows what to do, and the character can just smoothly transition between them. I like it.
Right. This pattern is great for creating more believable AI behaviors, smoother animations, even managing different phases of a game level.
Nice. You know how in some games sometimes events happen that kind of set off a chain reaction? Like the hero slays the dragon and this triggers a cutscene, unlocks a new area, grants some bonus experience points. How do we manage those kind of interconnected events in our code without creating this tangled mess of dependencies?
You're describing a perfect scenario for the observer pattern.
Okay.
Think of it like this. You have an event. Let's say the player scores a point.
Okay.
With the observer pattern, you can have other parts of your code subscribe to that event, and they'll be notified automatically when the event occurs without being directly connected to the code that actually triggered the event.
Okay.
It's like this really elegant way to decouple your code and make it more flexible.
So it's like having a news broadcast system in our game. Anyone who's interested can tune in to a specific channel, like player scored points, and then react accordingly.
That's exactly.
I like it. But what about situations where you've got a ton of things that are all listening for the same event? Doesn't that create like a performance bottleneck?
Yeah, that's a good point. If you have like hundreds of objects that are all vying for attention when a single event happens, that can definitely slow things down.
Right.
So as with any pattern, use it strategically, especially in those performance critical parts of your game.
Good to know. All right, we've covered a lot of ground here today. Factories, object pools, singletons, commands, states observers, each one a powerful tool for building better games. Before we wrap up this deep dive, any final words of wisdom from the design pattern playbook?
I'd say the biggest takeaway is that these patterns aren't just recipes to memorize. They're powerful tools for thinking about your code structure, for solving those common challenges that we face in game development in an elegant and efficient way. And the more you understand these patterns, the better equipped you'll be to write code that's not only functional, but also adaptable, maintainable, and ready to scale as your game grows.
Absolutely. To all you game devs out there, keep exploring, keep experimenting, and never stop leveling up your code until next time.